Hi everybody, welcome back to chemistry. In this video, we're going to go over how to do the post lab in Excel. So let's take a look the first post lab for lab 1, density of iron and aluminum. So let's take a look at our lab handout here. And we'll go down here. Post lab assignment. Okay, so you're going to submit your own post lab assignment. So even though you worked with another person, you are going to submit your own post labs. So you'll have the same data, and that's great. That's okay. So you're going to open up a Microsoft Word document or something, and you're going to put your name, your lab partner's name, CHEM140, the date of the experiment, and the experiment title. And then you're going to generate tables 1 through 4 in Excel. So these tables that you did in lab here. And then you're going to also generate some graphs in Excel, and I'm going to show you how to do that. So remember, in this lab, we took some data in those tables, and we determined the density of aluminum samples and iron samples, calculating on our own, right? Now I want to show you that you can do a bunch of those calculations in Excel. And the reason for that is that we use Excel in science because we take a lot of data points sometimes. And so calculating all of those, doing those calculations by hand can take a really long time. So Excel's really helpful in that regard. Okay, so let's set up the first 2 tables, and then you can do the second ones on your own, or the third and fourth on your own. So for the first table, let's say you started with aluminum. So for the first table, density of, and I apologize, my setup's kind of wonky here because I'm not using the iPad. It's really tedious to use the iPad to use Excel on the iPad, so I'm using my laptop. All right, so let's first title our table. So for that, so this is Excel, I forgot to mention. You have your title up here. This right now it's just called Book 1. You can change that later. And this is a sheet, so you can have multiple sheets. If you are like, where's all my data? It's gone. Check that maybe you have a couple sheets there. And these are like different pages in your Excel spreadsheet. So you'll notice that we have columns here that have letters, and then we have rows that have numbers. So for instance, if I'm in this cell, this is called a cell, this box here, I'm in A2. Okay, this cell is A3, A4, B4, B3, B2, and so on. Okay, so in this first cell, I'm going to start with creating my table, just the same thing that you have in your lab handout. So mass in grams. Remember, you always want the units. If you press tab, that scooches you over to the next column. If you press enter, that scooches you to the next row. Okay, so initial volume in mils. You'll notice that in this, I want to get to this cell here, but this one's kind of overlapping it. So what you can do is, if you hover over this little line here up at the top on your column, you can double click it, and then it'll auto fit that column so that it's as wide as the words in that column. Okay, so that's really handy. And then final volume, you've got the final volume after you put your metal in, right? Again, I'm going to auto fit that column. And then we also have, what do we have? The volume of the metal. Again, in mils. Always put the units in your column headers, right? And that way you can just put numbers here. So when you put the units here, that's assuming that everything in this column has units of milliliters. Okay, and then we have density in grams per ml. Capital L because we're in liters, and liters have a capital L. All right, so there's 2 parts to this, right? There's like getting the data correct, and then there's, formatting. Formatting is secondary right now. You don't need to have beautiful tables, right? Just as long as I can see all the information, your data's correct, that's fine. I don't need it to be beautiful. So we're not going to worry too much about formatting. So we had 3 samples, 1, 2, and 3. Your masses are going to be different than the ones I put in here. These are just examples. So they may or may not be close to what you had for your samples, and that's okay. They don't, you're going to report what you actually got in lab. I don't care about what I got in lab. I care about what you got in lab. So 5, 3, 2. Okay, so those are my 3 masses that I measured. And then I also have initial volumes. You'll notice that Excel automatically reports, it gets rid of that 0. So even though I typed in 30, oops, sorry, 30.0, oh geez, 30.0, even though I typed it in like that, it auto corrects to 30. So it doesn't really care about sig figs, but we do. So let's highlight this data. And let's show Excel that we actually did, we have those sig figs. So go to Format Cells. So right click on that data, go to Format Cells, and then go Number. Okay, and then for decimal places, I don't want 2, I just want 1, because when you're measuring this on your graduated cylinder, we know it gets to 30. If this was like 30.5, if I had a 5 there, that would mean that you at least got to 30 tick mark, but you didn't get it to 31 and you thought maybe it was right in the middle. Okay, it's 30.5. So this last digit would be estimated. But we want to show, hey, we filled it to exactly 30 mils, so we'll leave that like that. Okay, and now it shows that extra decimal place. If you wanted more decimal places, you would put, as many as you want. Okay, so now let's do our final volume. We got 34.2, 39.1, and 41.6. Okay, so we dropped our metal in, and then these are the final volumes we got. For now, this is the cool part of Excel. So Excel can actually do calculations for you. So in lab, you subtracted this, you took this number and subtracted this number from it to figure out, you took your final minus your initial to get your the volume of just your metal, right? We don't want the water volume, we want the metal volume. But in Excel, you can actually do that. So, and the way that you do that is you can double click on the cell, and that will show you've got your little typing spot there. And then you're gonna hit the equal sign, and that equal sign, and you'll see it popped up here, so watch that again. That equal sign is actually showing Excel, it's telling Excel that you're gonna put in an equation, okay, that you want it to actually solve an equation, or a function is another word for that. So you'll see this function bar here. Okay, so you can type in your equation up here in the function bar, or you can just type it in here. I'll do it both ways in here, so let's just do it in the function bar first. So what we want to tell Excel is what equation we want so that we can get our final answer here. So we want to take this number, right? So we're going to highlight that cell, click on that cell, and we want to subtract this number. So let me do that again. So I want this minus, put in your minus sign, this, and then you're going to hit enter. Oops, you're going to hit enter. And you'll notice that that's the correct number, right? You could have done that in your head. 34.2 minus 30.0 is going to give you 4.2, right? And then let's just double check that our formula is right. We could look up here and we could say D3 minus C3. Okay, well, I'm looking at this. This is D3, right? This is C3. Or you can double click on the original cell where we wanted the answer to come out, and you can see it starts color coding. So we want the blue column minus the red column. So that looks great. Okay, and this is an even cooler part about Excel is if you notice when you're click on the cell that you're that we just looked at, and notice that when I hover over this little square in the corner here, it turns into a like skinny plus sign. Okay, that's a fill. It's indicating that you can fill that formula down. Okay, you can also fill numbers down. Whoops, this should say 1. So if I started at, watch this, 1, sample 1, you can fill down like that, and it'll copy that over. You can also do 1, 2, and then delete that, and then it'll recognize this pattern here. Oops. Oh, I thought it would recognize that pattern. There we go. Yeah, if you you got to highlight both of these and then it'll recognize the pattern. Anyway, so you can use that fill function in lots of ways, and I encourage you to play around with it someday. In this case, what we want to do is fill this down to these other two cells so that we're copying that that equation. And Excel's really smart, and instead of copying D3 minus C3, those exact cells, it recognizes, hey, if I'm in this box, I want to take this minus this, and that's going to give me that answer. And then you can double check. So notice that now instead of highlighting these cells, it's highlighting the next one because it wants to populate this box. So it's smart. It recognized that we wanted, for this box, we looked to the left 1 and the left 2, and then it says, okay, well, now that we're in this box, we want this one to the left and this other one. Does that make sense? You can't answer me, sorry. I'm just used to saying that. Okay, and then you can check your work, right? 39.1 minus 30 is 9.1. 41.6 minus 30 is 11.6. So great, so that looks awesome. All right, and this is just a faster way. Imagine you had like 50 data points here. Doing all these calculations by hand would be such a pain in the butt, so you can just fill that down all the way down here. And if you don't have any values, it's just gonna be like 0, right? Okay, let's do our density now. So density is mass divided by volume, right? So we're gonna take this column, our mass, and which volume do we want? We want this one, right? We want the volume of our actual metal. We don't care about the volume with our water anymore because we determined the volume of our actual metal, and the density of our metal is what we're looking for. So again, put in your equals sign to let Excel know that you're going to do a calculation. And now we're going to do this column, or I'm sorry, this cell divided by, so backslash, this cell. Okay, we want mass divided by volume, right? Mass in grams divided by volume in mils. And then you'll notice that's where these units come from, grams per mil. Okay, press enter. And then we're getting like 3.4 something. Okay, now we can copy that equation down again. So, sorry, let me explain what I'm doing. Hover over that little box in the corner and pull it down. Okay, and it's going to auto calculate. So let's check and just make sure that that is correct. I'm going to double click. So yeah, it looks like blue is divided by red, and that's giving us that answer there. Same thing here. We're getting blue from this cell here. We're in the correct row, divided by red. Awesome. Okay, perfect. So now we want to calculate the average density. So let's write average density, oh gosh, density in what? Yeah, grams per mil, right? Because we wanted to calculate that average density. Let's just scooch this over just a little bit. I know that that looks kind of funky now because that's really long, but whatever. Again, formatting's not the most important part, right? Okay, so now, you know what we could actually do? Let's shorten this to AVG. That's a shorthand way of saying average. So let's go back to our the other one. All right, so now again, we want to put equals to let Excel know that we're going to do a calculation. And now we want to calculate the average density of these three numbers we have that we calculated for aluminum using water displacement. So you could, in lab, what you probably did was you took all these numbers, so you took your 3 data points, added those 3 data points up, and then divided by the number of data points you have, which is 3 in this case. So 3, this number plus this number plus this number equals what? And then divide by 3 because you have 3 data points. If you were taking the average of 2 numbers, you would add those 2 numbers up and then divide by what? Yeah, 2. If you were taking the average of 5 numbers, you would add those 5 numbers up and then divide by 5. You could do that, or you could do it in Excel. So the way I like to do it, and there's several ways to do it, you can go up here and you can click on one of the common functions, right? Summing is adding, Average is just taking the average like we're about to do. There's all these other kinds of things. And those might be relevant in future classes you take or, future projects, whatever. In this, the way I like to do it is I actually like, if you start typing, so I'm just typing in AVER, you can actually, it searches for functions. So I just want the regular average function, and if you're ever unsure, it has a little description. So double click that, I think. Yeah, double click it. And then it has this parentheses, so it's going to want you to list what numbers that you want to, or select what numbers that you want to average out. So I want to average out all of these. So now it makes a range. Anytime you see this colon here, it's telling you F3 to F5. That's what that kind of means. It's a range of numbers. But whenever you see a parenthesis, you got to end it, right? So we have to close that parenthesis, and then the description will go away, and you can press enter. Okay, so now what it did is it took the average of those three numbers. Yeah, and if you wanted to double check, you could say, okay, I wanted F3, right? F3 through F5. Okay, and that's what it did, F3 through F5, because I selected those. Okay, so we would expect, we have the highest density we got was 3.4-ish, and the lowest was about 2.6. So 2.9 is, yeah, like right in the middle there. So that's a good average density. So it makes sense. Always do that kind of like check at the end. All right, now that we're done with our table, let's go ahead and clean it up. So the convention is to have a single line under it. So go here, bottom border. It was already selected for me. And then you can do another bottom border after your columns. And then at the end here, after all your data, you can do another bottom border. And then you can see it's a little bit neater looking. Again, formatting is not the most important part, especially for the beginning labs. If this is like good, this looks great. You also, if you left off the borders, I'd probably be fine with that. So yeah, more important that you have these correct. If you're getting some weird numbers here and here, I'm going to be like, ooh, check your calculations. And that's more important to me. All right, so we got our first table. So let me show you how to make a graph. So Excel is really cool. Are we still recording? Yeah. Excel is really cool because I sound like I'm sponsored. But it's cool because it actually recognizes X versus Y in an XY chart. So if we have our X value here and our Y value here, and then we put some data points in and then highlight that data and make a graph, it knows exactly where to plot those data points. That's only if you put your X values on the left-hand side of a column. So let me show you what I mean by that. So we're gonna make a separate little table, and it's just kind of like a quick little XY plot, and I'll tell you why we have to do that in a little bit. So for this part, what we wanna do is we wanna try to graph the density using our Excel spreadsheet. So the two things that show density are mass and volume, right? That's the relationship. Mass divided by volume is your density. So in this case, I want my X value to be volume. So I'm going to type volume in mils. And then I want my Y value to be mass in grams. And I'll tell you why that is in a little bit. It'll make more sense. So I'm just gonna copy over these values, okay? And then put them in here. Okay, so for volume of my metal, I want these three values. So I'm gonna highlight them and then copy them. And then I'm gonna paste them over here. Control V is how you would paste. And you can see it's kind of freaking out because I copied this entire section and it's trying to keep my equation. But remember, our equation looked to the left and subtracted that from one more to the left. So right now it's like, what are you talking about? There's no numbers there. So let's go to here where you see paste options and then just go to, which one was it? Oh, just go to values. Yeah, and that's just going to copy over those values for us. Okay, and then in this column, we're going to do mass. So again, click copy, and then we're going to do paste. Oh, it recognized that I just wanted the values that time. Oh, we didn't, because we didn't have any equation there. Yeah. Okay. Let's actually color code this so that we can see what we're doing here. Let's go, I don't know, green, and then let's go blue. Blue. I don't know why I'm saying that. Blue. Okay. And then we'll make this blue. Sorry, we'll make this green. I don't know. If color coding helps you, that's great. If it doesn't, don't worry about it. And then I'm just going to put a bottom border there. Okay, so now I can see which exact ones I'm dealing with, right? I want my mass and my volume. Okay, so now look at this. You're going to highlight all of this data, and it's important that you have the volume column on the left because we want this on our x-axis, and I'll show you why that is in a little bit. So this goes on the left, green on the left, and blue on the right. So that's why I made a separate little table here, because right now if I just highlighted it like this, right, it would have mass on the left and volume on the right. So that would be confusing. There's also these other ones that are getting in the way here. So I just wanted to copy it over, and then that way it's easier to make a graph. So I'm going to highlight that data. There's several ways you can do this. The way that I like to do it is I like to go insert. After I've highlighted both of those data, and just the numbers, you don't want the titles, just the numbers. So go to data, then go in this charts section. You're going to go hit this little tiny arrow here. It's going to recommend some charts for you, and actually it's pretty dead on because we want this one, but I'm going to show you all charts. And then you're going to go to XY scatter. You might be tempted to hit line here. That's not the one we want. We want the XY scatter. Okay, so and then there's all these different kinds of options here, and if you hover over them, they'll tell you what they are. Okay, so you can see some of these here. We're actually going to add a trend line ourselves, so we just want the regular, and we want just this, an XY, right? We don't want this one. We want this one, so press OK. Alrighty. Now, let's just put that, I don't know, over here a little bit, I guess. I kind of want to be able to see my whole... I didn't mean to do that. If you ever make a mistake, you can also hit Control-Z, okay, and that'll kind of fix that for you. Okay, so now I can see the whole thing. Great. It is kind of bothering me that these are here, though. It's fine. Okay, so I'm just going to scooch this down. Okay, never mind. I'm being a perfectionist. Okay, so let's scooch over a little bit. Let's, the things that we want in this graph are a graph title, axis titles, a trend line, and remember this is all in your post lab. It tells you all of this, right? This is all the stuff you want in there. A trend line, an equation on the chart. So how do we add that stuff? Well, if you go to this plus up here, where that little plus sign, click on that, and then you can add some other things to your chart elements. So we want axis titles, we want a trend line. Okay, so now let's edit our chart title and our axis titles. So chart title is going to be, you want something descriptive. So something like density of aluminum, metal, using water displacement, and then you want your name and the date that you conducted the experiment. So 13/23 was today. And then let's make the font a little smaller so we can actually not take up the entire thing here with our title. Oops. What's happening? Okay, we'll just, why is it doing that? Scoot over. I don't know why it made my graph so small, but I guess that's okay. It's still legible. Okay, I'll scooch that up a little bit. All right, now let's change our axis titles. So it's kind of weird. If you can type, like, turn your head a little bit and you don't mind typing like that, you can type straight in there like that. If that bothers you, you can also type it in here. So if you're selecting, if you're on typing mode in this box. See how there's that line? You can type it in here and it'll replace it. So what's on our y-axis, we said that was the blue one, so mass in grams. Enter. And now it changed that for me. Okay, and then on this one it's horizontal, so I'm just going to type it myself, volume in mil. You could still enter it in up there, that's fine. Okay, enter. Oops, don't need to press enter, I guess. All right, so now I have a descriptive title. I have my mass in grams. I have my y-axis labeled, right, with units, okay? We have our x-axis labeled with our units. And then I want to click on this data, and remember that if you're in the not the app version, if you're in the web version of Excel, things are going to look just a little bit different. And one of the main things that looks different is data, how this comes up. So when I double click this in the app version, this is going to come up right away. In the web version, it might look a little bit different. So you might have to play around with it a little bit, but you're looking for something like this, format trend line, okay? It's linear. It already figured that out, so that's great. It's going to be a linear graph. You wouldn't be expected to necessarily know that. It's just something that I'm, letting you know. And then we want this one, display equation on chart. So check that box there, and that's going to show you your linear equation. So remember, for a linear equation, you have y equals mx plus b. Y equals mx plus b. What's m? That's your slope. Okay, what's your slope? Remember, slope equals rise divided by run. Your rise over your run. Remember that from algebra? What's your rise? Your rise is your change in y, and your x, or your run, is your change in x. Okay? So this is kind of cool. On your graph here, we're calculating the density using our data that we got, right? We're not using this. We're actually just using volume and mass data, and our density is our slope. Okay, so if you look at this, your rise is your mass in grams, right? That's on the y-axis. We plotted that with the blue column. And then your run is your x-axis, or your volume in mils. What's your density? Well, your density is mass divided by volume. Yeah. So kind of cool, right? I don't know. I think it's kind of cool. So you'll notice that your m value, your slope, is right here. Sorry, it's really just this m part, not the x. Okay? Y equals mx plus b, m is your slope. All right, we don't really need this y-intercept there, but you can leave it if you want to. It doesn't, we are not going to use anything related to that in this lab. It's just there, and that's okay. What I'm really concerned with is your m value, and how close it is to your calculated density. Okay, you'll notice that if you do take it off, hey, what's happening here? Let's click back on my data. I'll go to that one. Set intercept, you can set it to 0, and then you'll get a little bit more of an accurate number here. Okay. So we will go ahead and do that. So 2.7 is pretty close to 2.9. And then you can also, if you want to, you can include this display r squared value on the chart. That's just your fit, so that shows you how good of how good of a fit the data is. So under 1 is typically good. You can leave that on there. You can not leave it on there. I'm going to take it off just because it's not necessary. It's not listed in your lab handout as needing to be there, but in the future you will want your r squared in different labs, in future chemistry classes, maybe even in this one. All right. So that's your first graph, and it looks great. The other thing you could do is, I'm noticing a lot of blank space over here and over here. You could change the scale of your graph. So if you can figure out how to do that. Oh yeah, you gotta hit the numbers here at the bottom. There we go. and then go to the data part, and then go access options, and you're going to change the bounds. So for the minimum, I'm going to put 4 because I'm seeing that most things are happening around here. So I'm going to put 4, enter. That's going to make the data, like, make my line larger. It's just fitting the graph better. There you go. Okay. And then if you wanted like to show this, the y-axis better, you could even adjust the y-axis, but this looks pretty good. All right. Okay, that's your first graph. Now, I'll let you do the graph for your next metal using water displacement. Let's do this same metal. So table 2, density of aluminum metal. Oops, I showed this in the previous table. Aluminum metal, sorry, I know this is getting long. Measuring physical dimensions. Let's put by measuring physical dimensions. Okay, that's a pretty good title. And let's do, we got somewhat similar things, columns here. We got mass in grams, diameter, oops, in cm, centimeters. We got our radius, and I'm just copying the second table in your lab handout. Length, centimeters, whoops. We got more here, volume, and that's actually in cm cubed, right? We're working with centimeters. And then density, and now those units are also going to be a little different. Grams per centimeters cubed. Still a measure. Centimeters cubed is still a measure of volume, right? It's just, let's scooch that over a little bit. It's just a little different, represented a little bit differently. Okay. All right. So maybe I will actually scooch. Yeah, we'll scooch this up a little bit just so we have all of our tables, and then we can just put all of our graphs here. That's fine. Okay, again, we had 3 samples. We have the same masses, so I'm actually just going to copy and paste. I want just the values though. Diameter, that was something you measured in lab. So when I measured it, I got 1.25 centimeters each time. Okay. And then your radius is your first calculation that you're going to do. Okay, so your radius for, how do you calculate for the radius? Yeah, your radius is half of your diameter, right? So again, let's do this, equals, to let Excel know we're using an equation. We're going to go this divided by what number? Yeah, 2. We're going to cut it in half. Yeah. All right, now Excel's smart, and it's going to say, okay, now we're going to fill in this one, and we are going to take this number divided by 2. It happens to be the same number, so we'll get the same number every time. But if it was a different number, like 1.5 maybe, you see it immediately changes it, right? Because now it's taking this and dividing by 2. Okay. So let's just go back though. We want it to be accurate. All right, the next thing we measured was the length in centimeters. So we got 3.3 centimeters for this one, 7.2 for this one, and 8.7. Remember, your numbers are going to be different than mine. Don't use mine as a gauge. I picked random. These are like random numbers. So don't stress if yours don't look the same or even very close. All right, volume. Now we got to calculate that again, right? So remember, volume of a cylinder. How do we calculate the volume of a cylinder? Well, it's in our lab handout. Let's go back up here. You might have done it already in lab. That's great. Okay, so volume equals the area of a circle, or the areas of the circles, right? There's 2 circles. And then times the length. So that equals pi r squared times the length. All right. Okay, so let's try to put that in Excel. So do our equals, and then you could type in pi, and it actually knows the value of pi. So let's, we could do that. You could also just put in like quite a few decimal places, so 3.14159. I had to memorize that in school, so I remember that number. But you could just hit pi. I actually find it a little bit, it's kind of looks weird, so let's just type it in, 3.14159. It's just because it starts putting in parentheses and then it looks a little messy. So just for simplicity's sake, let's do it this way. So we're going to take pi and we're going to multiply that by what? R squared. So r squared is just r times r. R is our radius, right? So you could do r squared. You could do a exponent in here, or it's just squared. So let's just do this and then times the same thing. And then times what else? So pi r, pi times r, or r squared, right? Times our length. So now you can just click on this one. So once you hit enter, let's check. Is that a reasonable value? I think so. And then let's double check. Notice that we have our pi value is in black. That's kind of like anything that you just type in is going to be in black. If it's an actual cell, it's going to color code it. So we're going to have blue times red. Okay? All right. Again, we can fill that in and it's going to calculate. It's smart enough to know that now we don't want these two columns. We want these two. Or these two cells. We want these two cells. And that looks great. Okay, density. Again, equal sign. And then density is what? Grams divided by volume, or I'm sorry, mass divided by volume. So we'll go click on that, put our little backslash, and then click on that and press enter. I'm going a little fast because this is the second time we've done this now. All right, so now let's get our average density G per cm cubed. That little caret just shows that that's an exponent, so an exponent function. So it's showing that cm is raised up, right? Raised up to the power of 3. Okay, that's kind of annoying that it's like that. That's okay. I don't want to mess with these columns. I guess I could a little bit there. Yeah, that's fine. All right, so again, equals sign. Average, AVER, double click that, and then we want these three, and we want to close off our parentheses, and we get our number here. Okay, I guess we'll just do this. Yeah, I don't know, you know, it's it's kind of annoying. I guess I'm a perfectionist. Anyways, okay, so we see the average is 3.07, 3.08-ish, and then that's between 3.57 and our lowest, which is 2.8. Yeah, so that's a reasonable average, right? Okay, let's go ahead and do the same thing that we did last time and make a couple different XY chart. So again, we want the mass to be our Y value. So let's make that blue. Which blue did I use? That one. And then we want our Y or X value to be our volume. Okay, so let's actually, I'm gonna put it here, volume. And you're not turning in this Excel. You are turning in, you're gonna copy and paste these over, and I'll show you how to do that over to your Word document. All right, let's copy these, and we're gonna paste them here. And we just want the values. Okay, copy these, paste them here. We just want the values. There we go. All right, let's color code it. We want green and blue. And then I guess, I don't know, we'll put a little line here. There we go. I'll actually add a little line here too, just so that we show that that's over. Great. Okay, now we have our data points. Excel is going to recognize that this is your X and this is your Y. Highlight those, both of those values, just the numbers, and then you're going to make a chart. So another way you can make a chart is you could go here, click on that little quick analysis, go to charts, and then go scatter. And then it'll come up with the same type of chart. Okay, scooch it a little, make it a little smaller. All right. Now, descriptive chart title, let's go, I don't know, density of aluminum. What did I call this one? Aluminum metal by measuring, I don't know, physical dimensions, whatever. And then Kayla Shaffron is, you put your name and then the date that you did the experiment, not the date you're turning this in. Oh, no, that's not right. 13/23. Is that how I formatted it? Yeah. Okay, and then we're gonna make this a little bit smaller. We don't need our title to take up the entire space. Okay, great. Now hit the plus sign, axis titles, trend line. Let's edit our axis title. Mass is on your y-axis, mass in grams. Okay, and then, oops. Hey, go away. Volume in mils. Okay, great. All right, let's click on your data and format that data. So, why is it doing that? There, I wanted to look at the trend line. Okay, so I had to click on trend line. All right, it's linear. We got that. We want to set our intercept to 0. Great. We want to display our equation on the chart. We're going to move that equation just so that it's visible. We maybe want to fit the data better. So let's go ahead and click on that data. And then we'll go. Why is it showing it different than last time? I don't know. I don't know. Oh, just because I'm clicking on the wrong thing. Great. Axis options, and we're going to make this, let's go, I don't know, let's go 3 this time, just because it looks like it's right on the 4 there. And then we can end it on, it looks like it doesn't even get to 11, so let's end it on 11 for that. The up and down looks all right. I guess we could make it a little bit different. We could put, I guess that's fine. Yeah, it's fine. Okay. I mean, yeah, let's change it. I'll just show you how, so that you know how to change the Y. So now I clicked on the Y data, or the Y axis values. So let's make the minimum, looks like maybe, let's make it 10. Excuse me, why can't I? Hello? Huh, it won't let me click on it. Oh, is my computer frozen? There we go. Okay, I don't know. It froze for a sec. There we go. That looks great. Okay, so now we can see that graph really nice and clear. We've got a descriptive title. We've got our chart. We got all the things that our PostLab asks for on our chart. And now we're probably ready to copy and paste. So zooming out just a little bit here, we can move this back up here now. I don't know why I moved it in the first place. We can move these a little bit. Oops. Great. And then you're going to have 2 other tables, right? And you're going to have 2 other graphs. You can either put them here, you can put them down here, whatever. You're not turning in this actual Excel spreadsheet. What you are going to do is you're going to copy and paste. So let's open a Word document. Blank document, whatever. And then we, are going to take, copy this over, copy. And I just selected all of it and just hit copy. Okay. Actually, let me do that again. So select all of it and hit right click, copy. Okay. And then you're going to go back to your Word document. You're gonna have some stuff here, whatever, it'll have your name and stuff like that. You'll have title, whatever, and then this will be centered, and then you're gonna paste that graph in. So Control V, or that table, sorry. You have a couple different options. You'll notice when you paste it, it'll show this. So keep source formatting. That means the source of where it came from. So your Excel, right? You can try the destination style, which is going to make it look like your destination. So Word, which is what you just opened. You can try all these different ones. Whatever works better for you is totally fine. You can insert it as a picture, which actually makes it really easy to go like this. But it's less editable. So in the future, so if you ever need to change any of your data points, you can't do that. Because let me show you, if you Control V, if you put it in like this and you change this data, it actually works like Excel. So I don't know, 14.7. Let's do 14 point, I don't know, 6. Oops. It'll actually, oh, I thought it would change the number. Maybe it won't. I think there is a way to, one of the options allows you to, when you change it in here, it'll actually change the value here. So it copies the Excel, the whole Excel function. I can't remember which one that is. It's not really important for our purposes, but you get the gist. And we can play around with it and I'll figure it out as well. Okay, so that's that. Let's also copy this graph. You need tables and graphs for your post lab, right? So let's copy the graph. I just literally did copy and paste. You can do table, graph, so table 1 and its graph, table 2 and its graph, or you can do all your tables, table 1 through 4, and then all your graphs, graph 1 through 4. Totally up to you. I don't really care. As long as I know which, as long as you have a descriptive title that allows me to know that these two are related, right? That this is the graph that goes with this data, then that's fine. If you don't label this and you put it somewhere on another page, then I'm going to be confused and I'll probably mark you down because it's not descriptive enough to allow me to actually analyze your data, right? Okay, so you're going to have 4 of those tables, 4 of those graphs. You hit any snags, let me know. And I think that's it for today. I don't want this video to be much longer. Okay, have a good rest of your day. Bye.